Last episode, you built a classification pipeline and hit F1 of 83%. Today is different. There is no target column, no label, no right answer written in the data. Your job is to find structure that nobody told you was there and turn it into a business recommendation. Hi, I am Mahaz, an AI engineer. Last episode, Capstone 2, classification pipeline, customer churn, smoke plus XG boost, F1 of 83. Today, Capstone Project 3, Unsupervised Segmentation and Marketing Analytics. Episode 37. The final capstone. The Dataset, a marketing campaign table from the UCI Machine Learning Repository. 2,200 customers. 29 features. Income, spending on 6 product categories, number of purchases per channel, campaign responses. No target column. That is the whole point. You are not predicting anything. You are discovering. Key feature groups, demographics, age, income, education, marital status. Spending features, amount spent on wine, meat, fish, sweets, gold, and fruit in the last 2 years. Behavior features, number of web purchases, catalog purchases, store purchases, and campaign responses. First step, df.info and df.describe. Know your shapes and distributions before touching anything. Cleaning. For steps. First, income has 24 missing values. Impute with the median, not the mean. Income distributions are skewed. Second, derive age from year of birth. Derive total spend as the sum of all 6 spending columns. Derive tenure years from the customer join date. Third, drop raw date columns, customer ID, and Z_ columns that carry no signal. Fourth, scale everything. KMeans and PCA are both distance-based. Unscaled income, which is in thousands, will dominate number of catalog purchases, which is in single digits. Use standard scaler. After scaling, every feature has mean 0 and standard deviation 1. Distance calculations are now fair. Step 3, PCA. Why do you need it before clustering? You have 29 features. KMeans computes distance in 29-dimensional space. In high dimensions, distance becomes meaningless. Everything is roughly equidistant from everything else. This is the curse of dimensionality. PCA finds the directions of maximum variance in your data and projects it onto a lower dimensional space. You keep enough components to explain 90% of the variance. On this dataset, that is typically 8 to 10 components. Then you also project to 2 components for visualization, so you can see the clusters on a 2D scatter plot after training. PCA does not throw away information. It compresses it. The first 2 components capture the most important axes of variation in your customer data. Step 4, K-means and the elbow method. You need to choose K, the number of clusters. Run K-means for K equals 2 through 10. For each K, record the inertia, the sum of squared distances from each point to its nearest centroid. Plot inertia versus K. The curve will drop steeply, then flatten. The point where it bends, the elbow, is your optimal K. On this dataset, the elbow is at K equals 4. For customer segments, confirm with silhouette score, which measures how similar each point is to its own cluster versus other clusters. Set random state for reproducibility. Run K-means with n clusters equals 4 on your PCA reduced data. Each customer now has a cluster label, 0, 1, 2, or 3. Step 5. Visualize the clusters in 2-dimensional PCA space. Project your data to 2 PCA components. Plot each customer as a dot colored by their cluster label. For clearly separated clouds of dots. That is what a good clustering looks like. The clusters have structure, they are not random noise. Mark the centroid of each cluster with a larger star marker. The centroid represents the average customer in that segment. This scatter plot is your first deliverable. You can show it in a slide deck and immediately say, we have 4 distinct customer types. Step 6, profiling. This is where unsupervised ML becomes business value. Group the original data by cluster label. Compute the mean of every feature within each group. Cluster 0, low income, low spend, many web visits. Likely young or budget-conscious customers. Call them the browsers. Cluster 1, high income, very high spend on wine and meat, few web visits, many catalog purchases. Premium offline shoppers. Call them the loyalists. Cluster 2, mid-income, mid-spend, highest campaign response rate. Most marketing receptive segment. Call them the engagers. Cluster 3, high income, moderate spend, highest number of store visits, low campaign response. Habitual in-store shoppers. Call them the store champions. Give each segment a name. A name makes it actionable for a marketing team. Step 7. Apriori association rules. What products do customers buy together? Convert your spending data into a binary matrix. Each row is a customer. Each column is a product category. A 1 means they bought above the median threshold for that category. Run the Apriori algorithm with minimum support of 20%. A rule passes support if at least 20% of customers match both sides. Filter by confidence above 60% and lift above 1.2. Confidence is how often the rule is correct. Lift above 1 means the rule is better than chance. Top rule. Customers who buy wine also buy meat. Support 32%. Confidence 71%. Lift 2.1. Second rule. Customers who buy fish also buy fruit. Support 26%. Confidence 64%. Lift 1.8. These rules power the frequently bought together section of a recommendation engine. No deep learning required. Step 8. Writing the business report. This is the output that actually matters. Your report has 4 sections. 1. Executive summary. What did you do? How many segments? Key finding. 2. Segment profiles. For each of the 4 segments, state the name, size, key characteristics, and 1 recommended marketing action. Browsers. Target with email campaigns for entry-level products and loyalty program signups. Loyalists. Prioritize catalog and premium bundles. These are your highest value customers. Do not waste budget on discounts. Engagers. Run A/B campaigns on this group first. They have the highest response rate and give you the fastest feedback loop. Store champions. Focus on in-store promotions and loyalty cards. They are unlikely to respond to digital campaigns. 3. Association rules summary. Top 3 rules with support, confidence, and lift. 4. Limitations and next steps. Step 9. Saving the pipeline so you can score new customers. Save the standard scaler and the PCA object fitted on training data. Save the KMeans model. Use joblib.dump for all 3. To score a new customer, apply the scaler, apply PCA, then call KMeans.predict. You get back a cluster label in milliseconds. Bundle the scaler, PCA, and KMeans into a single pipeline using Sklern pipeline, so scoring is always one call. No manual step order to get wrong. Version the file with the date and silhouette score. Cluster assignments can shift as your data grows, so always retrain periodically. Recap. 9 steps. 1. Complete unsupervised analytics pipeline. Inspect. 29 features, no labels. Understand the feature groups first. Clean. Impute income, derive age and spend features, drop noise columns. Scale. Standard scaler makes distance-based algorithms fair. PCA. Compress to components that explain 90% of variance. Project to 2 dimensions for plotting. KMeans. Elbow method picks K equals 4. Silhouette score confirms it. Profile. Compute per cluster means. Name each segment. Write 1 marketing action per segment. Apriori. Binary matrix. Support 20%. Confidence 60%. Lift above 1.2. Find the product rules. Report. For segments. Top 3 association rules. Recommended actions. That is business-ready output. 3 capstones done. Regression. Classification. Unsupervised. You now have a complete machine learning toolkit, supervised and unsupervised, from raw data to production-ready pipeline. The next series starts soon, deep learning from scratch. Neural networks, backpropagation, convolutional networks, all built step by step. Subscribe so you do not miss the first episode. It drops very soon. Challenge. Load the UCI online retail dataset from Kaggle. Build RFM features. Recency, frequency, monetary. Apply this exact pipeline. How many segments do you find? What is your strongest a priori rule? Post both in the comments. Code outline is in the repo. Link in the description. You do not need a label column to learn from data. The structure is already there. Your job is to find it. 3 capstones. 3 complete pipelines. You are no longer a beginner. Deep learning is next. The foundation you built here will make it 10 times easier. Subscribe. The next chapter starts soon. Drop your segment count in the comments. I read every one. See you in the Deep Learning series.